Hi middle one, our lesson today is about equations and inequalities. Remember that the equation is two or more algebraic expressions connected with equal sign, like 2x plus 4 equals 6. Here I need to find the solution set of the following equation in the set of natural numbers. Here x plus 2 equals 5. To solve any equation, our target is to keep the variable alone in one side. Then I need to get rid of this plus 2 to have x alone in one side. I can do it by adding the additive inverse of plus 2, but I should add it to both sides, like this. Here x equals 5 minus 2, which is 3. We have another way. Circle this plus 2 and throw it to the other side by the opposite sign or the opposite operation. Then x equals 3, and the solution set in the set of natural number is 3. Here another example. I need to keep x alone in one side by adding its multiplicative inverse, or by dividing both sides by 3 to get rid of this 3. Here I can find x alone in one side, and then in the other side 6 divided 3 equals 2. And by the other way, we can circle the 3 and throw it to the other side by the opposite operation. 3 multiplied by x, through it by dividing, then 6 divided 3 equals 2. In the question, he asked me to find the solution set in the set of natural number. Then the solution set here is 2. Another example, I need to find the solution set of this equation in the set of natural number n. First, get rid of the plus or minus. After that, get rid of times and divide. Then through this plus 8 to the other side to be negative 8. 2x equals 4 minus 8, which is negative 4. After that, get rid of this 2. Throw it to the other side by doing a dividing, opposite operation. Then x equals negative 2. Here, the solution set in the set of natural number is 5, because the set of natural numbers has no any negative integers. Another example, I need to find the solution set in the set of integers z. First, through this plus 5 to go to the other side, negative 5, then 3x equals negative 1, then x equals negative third. Then the solution set in the set of integers also equals 5, because the set of integers has no rational numbers or has no fractions. While the same example, if I need to find the solution set in the set of rational number q, here I can find the solution because the set of rational numbers accepts all fractions. Then the solution set here equals negative third. Here let's remember how to translate certain verbal statements into algebraic expressions. Two numbers, their sum is 5, then these two numbers x and 5 minus x. Two numbers, their difference 5, then these two numbers x and x plus 5. Two numbers, their product 5, then these two numbers x and 5 over x. 8 subtracted from 3 times a number x means 3x minus 8. 3 consecutive integers, I can support them like x plus 1 and x plus 2, while 3 consecutive even integers or odd integers, I can support them like x plus 2 and x plus 4. Now let's talk about the inequalities. The only difference between the equations and the inequalities that the inequalities is two or more algebraic expression but connected with inequality sign. And let's remember the inequality signs: greater than, smaller than, greater than or equal, and smaller than or equal, and also not equal from the inequality signs. How to solve the inequality? By the same way we used it to solve the equation. Here I can first add the additive inverse to both sides of the inequality to have x smaller than 3. Or we can circle this plus 2, throw it to the other side, negative 2, to have also x smaller than 3. Here I need to find the solution set of the inequality in the set of natural number. Then the natural numbers smaller than 3 as 0, 1, and 2. Here also we can solve the inequality by divide both sides by 3 to have x smaller than 2, or we can circle the 3 and throw it to the other side by dividing to have also x smaller than 2. I need to find the solution set of the inequality in the set of natural numbers. The natural numbers which are smaller than 2 are 0 and 1. Another example, let's circle this negative 2, throw it to the other side to have plus 2, 3x smaller than 9, and let's throw the 3 to the other side by dividing to have x smaller than 2, and the solution set in the set of natural numbers is 0, 1, and 2. Here to find the solution set of the inequality in the set of integers z, let's circle this negative 3, throw it to the other side plus 3, then 2x smaller than 4, circle this 2, throw it to the other side by dividing, then x smaller than 2. The integers which are smaller than 2 are 1, 0, negative 2, negative 1, negative 2 till negative infinity. Middle one, let's see this inequality. Negative x greater than 0. Which number satisfies this inequality? If we put x with any positive number, then like 3, negative 3 greater than 0, it's wrong. Then the value of x should be negative number. Then x smaller than 0. Let's have here very important rule that if we divide it or multiply by any negative number, we should flip the inequality. Now let's solve this inequality. Circle negative 2, throw it to the other side plus 2, then negative 2x smaller than 4, circle negative 2, throw it to the other side by dividing by negative 2. Here we should flip the inequality to have x greater than negative 2. Then the solution set in the set of integers is negative 1, 0, 1, 2 till positive infinity. What about if we are going to solve the same inequality in the set of rational number q? Here, negative 2x smaller than 4 divided by negative 2, then x greater than negative 2. How to write the solution set of in the set of rational number? We can't put the solution set by the listing method. We should write it by the descriptive method like this. Solution set is x such that x belongs to q and x greater than negative 2. Now let's see how to solve this type of inequalities which have three sides. Here we should use the way of adding the additive or multiplicative inverse. First, let's get rid of this negative 2 by adding its additive inverse plus 2 to the three sides. Here we have 2x greater than or equal 8 smaller than 12. Then let's get rid of this 2 by dividing both or the three sides by 2 like this to have x greater than or equal 4 and smaller than 6. Here the solution set in the set of integers is 4 and 5. About representing the inequalities on a number line, an open circle means that the value is not included, like x greater than 2. We represent it like this, open circle and all these values. X smaller than 5, here open circle in 5 and all these values in the side of negative. A filled in circle means that the value is included, like x greater than or equal 3. Close the circle and all these values in the direction of the positive. X smaller than or equal 6. Close the circle in 6 and all the values in the direction of negative. Now let's have certain exercises. X plus 2 equals 13. X belongs to n. I need to find the solution set of this equation in the set of natural number. Here plus 2 go to the other side, negative 2, then x equals 11 and the solution set is 11. Here second one, 8x plus 4 equals 12, plus 4 go to other side, negative, then 8x equals 8, then x equals 1 and the solution set is 1. Here let's collect the like terms first, then 6x minus 2x, 4x plus 7 equals 4, then this plus 7 go to next side, negative 7, then 4x equals negative 3, then x equals negative 3 over 4. I need to find the solution set in the set of integers, and integers has no any rational numbers, then the solution set is 4. Solve the following equations in the set of integers z. Here x plus 1 equals 4, then x equals 3, and I need to find the value of 8x, means 8 times 3 equals 24. What about this type of equations? Here we should break brackets first. 2 multiplied by both x and negative 7. 2x minus 14, and this negative 1 multiplied by both x and 3 to have negative x, negative 3. Collect like terms. 2x minus x equals x, negative 14, negative 3, negative 17, then x equals 17 and the solution set as 17. Here I need to solve the inequalities and to represent the solution set on the number line. First, collect like terms. Here we have 6m minus 5m, m greater than or equals negative 14 go to the other side, plus 14, then m greater than or equals 12. In the set of integers, solution set is 12, 13, 14, 15 till positive infinity. To represent this solution set on the number line, starting from 12 and 13 and 14, and with this arrow to represent that the solution set extended to reach positive infinity. Next, here let's break brackets. 4x plus 4 smaller than 3x minus 9. Here collect like terms, then x smaller than negative 13. To represent or to write solution set in the set of rational numbers, represent it by descriptive method. Solution set equals x such that x belongs to q and x is smaller than negative 13. And to represent it, put open circle in 13 and cover all this space to reach negative infinity. Thanks for listening, and we're gonna meet in other lessons.